Alright guys, we're going to continue with our discussion on hydrocarbons and organic chemistry. And we're going to start off with the simplest of all hydrocarbons, the alkanes. So let's start with that. Alkanes are basic hydrocarbons. That means they only have carbon, and hydrogen and carbon, hence the name hydrocarbons. And each carbon atom in all alkanes are linked to 4 other elements in single covalent bonds. Alright? They're linked by 4 single covalent bonds. And this 4 single bonds makes alkanes to be saturated. That means you cannot, in any physical way, add more elements to that carbon atom. No way. It's saturated. There's the maximum amount of elements you can attach to that single carbon atom. Okay? So it's saturated. Now, alkanes are mainly products from fractional distillation from the oil and gas industry. And the amazing thing about alkanes, like almost all hydrocarbons, is that they are packed with lots of energy. Hydrocarbons are known to contain more energy than other sources of power, like batteries, or light, or solar, or wind power. They have more energy in them than any other source of alternative fuel. Alright? And the amazing thing about hydrocarbons is that they are so easy to transport. You can put all of them in an oil tanker and ship it across the world to remote areas, and you can deliver your hydrocarbons to that new place. Alright? And because they're so easy to transport and they pack up a lot of energy, the amazing thing about hydrocarbons is that they are unreactive. They only react when you burn them. So if you don't introduce a spark or ignition source, hydrocarbons should not react spontaneously in nature. Alright? So now that we've got a little introduction on hydrocarbons, we're going to learn how to draw the structural formulas or the Lewis diagrams for the simple alkanes that I've put here. In class, we're going to talk about more. In class, we're going to do a lot more exercises to extend this ability. So, first, let's start off with methane. As I talked about in the last class, I gave you a list of prefixes as well as the functional groups. All right. So let's start off with methane. Methane has the prefix meth, which means 1. And A means that it is a saturated hydrocarbon. It means that single carbon atom is linked to 4 other elements. Okay? So first you draw the C to indicate that you have 1 hydrocarbon, 1 carbon because of the name methane, and the rest should be linked covalently to hydrogen. So you have 1, 2, 3, 4. This is methane. What about ethane? Ethane means eth means 2. So you should immediately first, when you draw the Lewis diagram, you should immediately draw the 2 carbon atoms. Okay? Like so. And then you're going to connect the remaining unbonded sides of the carbon atom with 6 other hydrogen atoms. Alright? So you may ask me at this point, Mr. Ko, how do I know how many single bonds carbon can make. Remember what I talked about, the valence electrons of each carbon has. Each carbon atom has 4 valence electrons. So it is possible for it to make a combination of bonds, but because this is a saturated hydrocarbon, it is allowed to make 4 single covalent bonds. Alright? So if you look at each carbon, you will see that it's bound to 4 single. It will have 4 single covalent bonds to other elements. So for this carbon, you have 1 bond, 2 bond, 3 bond, 4 bonds. And for this carbon, you have 1 bond, 2 bond, 3 bonds, 4 bonds. It is that simple. Alright, propane. Prop is the prefix for 3. So immediately you draw 3 carbons. And you're going to fill up the rest with hydrogen. Okay? And the formula for that, you count all the hydrogens, it will be 8 hydrogens to 3 carbon atoms. And finally, as an example that we will use today is butane. But means 4, so you have to draw 4 carbon atoms linked together by single covalent bonds, and fill up the rest with hydrogen. Fill up the rest with hydrogen. It is that simple. So, after looking at all these formulas for alkanes, you can derive a general formula for all alkanes, which is CnH2n plus 2. That is the general formula for all alkanes. And if you look at all these alkanes, it will have the most prominent of all bonds that you see is the CH bond, right? It's this CH bond. Lots of it. Lots of CH bonds. Okay? Look at it. This is the functional group of all alkanes. It doesn't really do much. It's not as reactive, remember that. So you can't really do much reactions with it except if you combust it. Alright? So all alkanes will have similar chemical properties due to its CH functional group. And so you can call all alkanes and label them as part of a homologous family. Okay? Homologous. Series or group or family of hydrocarbons. Okay? That means they will all behave the same under whatever circumstances that you put it through. Alright, now let's move on to a quick topic on combustion of alkanes. Now remember we talked about alkanes being unreactive except when you burn them. When you burn them, you break those bonds. Alright, you're going to break the bonds of this alkane and energy is released. And the minute energy is released, new bonds are going to get reformed in a form of carbon dioxide or carbon monoxide, and also water vapor. Okay? So, and a lot of heat and energy, which is used to do all sorts of industrial applications or driving of cars or whatever it is. So, combustion of alkanes is when I'm going to take methane as an example. I'm going to take methane as an example and burn it in the presence of oxygen because you need oxygen as part of the combustion triangle. A combustion triangle simply states that in order for combustion to be successful, you need three elements. A fuel source, which could be any of the hydrocarbons, oxygen, and an ignition or source of the combustion, spark or anything to allow the reaction to get started. Okay? Now, I've written down a balanced formula for methane reacting with in the presence of oxygen. When we have sufficient and lots of oxygen in the atmosphere, methane can completely combust to produce carbon dioxide and water vapor. And this is known as a complete combustion. But when you limit the sources of oxygen, you will have incomplete combustion that will have products that come in the form of carbon monoxide or even carbon black soot, right? And these are products of incomplete combustion. And finally, we're going to talk about isomers. Isomers are basically alkane chains. When they get long enough, we can rearrange them into different configurations. That means we can rearrange how the carbons are placed when we draw them out. And this will also affect the naming of the isomer. All right? So let's take a look at butane again. Butane has four carbon atoms linked covalently, single covalently bonded to all the hydrogens. So in actual fact, we can call this n-butane. N meaning normal. Let me write this up here. N-butane. Okay? Here I have another diagram. Let me try to adjust it down here a little bit. Here we have another structural diagram of 4 carbon atoms. And so it's an isomer of n-butane. However, because of its structure and the outlying carbon atom over here, the naming mechanism changes. When we work with the nomenclature of organic compounds, we will first start off with counting the carbon chains. All right? So let's do this. We will make this carbon 1, carbon 2, and carbon 3. Or we can rename it carbon 1, carbon 2, or carbon 3. No matter how you count your carbons, you are going to see that it has a maximum of 3 and it's its longest chain. Now this may not make sense to you right now, but when we talk about longer alkane or hydrocarbons, you will see this naming mechanism come into play, and we will do this exercise in class. So you count the longest chain that you can possibly count, and we've identified it's only 3, and then you're going to use that as your root name. So 3 carbon means prop. Remember that, prop. And because the longest chain is saturated, so it should be propane, right? And now we have identified this being propane. And right here we have a methane group. But this methane is not exactly methane with 4 hydrogens. It's methane with 3 hydrogens attached to a central carbon atom. So instead of calling this methane, we will add the suffix O in it, O. So what is the prefix? It's meth. And we add it with the suffix O, so methyl. So we call this methyl propane. This is the isomer. Name of the isomer that is name of this compound that is an isomer to n-butane. Now, technically, it should be called 2-methylpropane because this methyl group is connected to carbon number 2 in the long chain. But because there's only one configuration of this methylpropane, people normally just drop the 2. But it's not wrong to keep the 2. It's just general practice. Chemists are lazy, and like all lazy people, we tend to try to shorten as much as we can when we do this naming system. So that is it for today, and we'll do more exercises in naming and writing structural formulas.